Your car has 97,000 miles on it. It's running fine. You're not worried. Then one morning, you turn the key, hear a strange gurgling sound, and by the time you pull into work, the temperature gauge is buried in the red. 3 days later, a mechanic hands you an estimate for a new engine, $6,000 to $9,000. And the cause? A $12 plastic impeller inside your water pump that cracked and stopped moving coolant. This is happening to people every single day. And the worst part is, it is almost completely preventable if you know what to look for. So let's talk about what's really going on inside modern engines around the 100,000-mile mark, why so many of them are failing at almost exactly the same mileage, and what the water pump has to do with all of it. First, some quick context on why this matters more now than it did 20 years ago. Older engines were heavy, simple, and overbuilt. The components inside them, water pumps, timing chains, and thermostat housings, were made of metal, cast iron, aluminum alloy, materials that could take heat, pressure, and years of abuse. They were not glamorous, but they lasted. Modern engines are engineered differently. Automakers are under enormous pressure to cut weight, reduce emissions, and hit fuel economy targets. So, over the past 20 years, many of the components that used to be metal were replaced with high-strength plastics and composite materials. And in most cases, that is fine. Plastic has come a long way. It is lighter, cheaper to manufacture, and good enough for plenty of applications. But here is where it gets complicated. Some of those plastic components are sitting right in the middle of your cooling system, one of the most thermally stressed environments in the entire engine. And when plastic lives in a world of constant heat cycles, pressurized coolant, and chemical exposure for 80,000 to 100,000 miles, it does not always hold up the way metal would. The water pump is the heart of your cooling system. Its entire job is to circulate coolant from the radiator through the engine block and back again, keeping everything at a stable operating temperature. If it stops doing that job, even for a few minutes at highway speed, engine temperatures spike fast, head gaskets fail, aluminum heads warp. In severe cases, the engine is destroyed. Now, here's what changed. Many modern water pumps, particularly in European brands, but also increasingly in domestic and Asian vehicles, use a plastic impeller. The impeller is the spinning component inside the pump that actually moves the coolant. On older pumps, that impeller was metal, stamped steel, or cast iron. It was pressed onto the shaft, and it stayed there. On many newer pumps, the impeller is injection-molded plastic, and it is mounted onto a metal shaft. The problem is that plastic and metal expand and contract at different rates when they heat up and cool down. Over years of thermal cycling, that bond between the plastic impeller and the metal shaft can weaken. The impeller can start to spin independently of the shaft, or in some cases, it can crack entirely. The pump looks fine from the outside. It is not leaking. It is not making noise, but it is not moving coolant properly or at all. Your temperature gauge may not even spike immediately. The engine might run slightly warm. You may see no warning signs at all until the coolant is not circulating and the damage is already happening inside. This is not a rumor or a conspiracy theory. Plastic impeller failure is a well-documented issue that has affected a range of vehicles, from certain Volkswagen and Audi models to BMW water pumps that became notorious for failing well before 100,000 miles, and to various other makes where the same design philosophy was applied. Online forums for specific models are full of people who experienced the exact same failure at similar mileage, often with zero prior warning signs. The reason the 100,000-mile mark comes up so often is simple. That's roughly how long the plastic can handle the stress before degradation becomes a real risk. It is not precise. Some pumps fail earlier. Some, last longer. But there is a reason so many people report this happening in that 80,000 to 120,000 mile window. Here is the frustrating part. When a vehicle is under warranty, these failures are covered. The manufacturer fixes it, and nobody hears about it. Once that warranty expires, the failure happens on your dime. And because the pump looks fine externally, you might be misdiagnosed at first, chasing other cooling system problems before anyone pulls the pump apart and finds the real cause. So what can you actually do about this? The first thing is knowing whether your car is at risk. If you drive a European vehicle, particularly one from VAG or BMW, and it is approaching or past 80,000 miles, it is worth doing specific research on your model and the water pump design used in your engine. Many mechanics who specialize in these brands have seen this failure enough times that they now recommend replacing the water pump proactively at certain mileage intervals, rather than waiting for it to fail. The second thing is understanding your cooling system maintenance schedule. Coolant degrades over time. Old, acidic coolant is more chemically aggressive on plastic components and seals. If you have never flushed your coolant, or you do not know when it was last done, that is a problem worth addressing, regardless of what your pump is made of. Fresh coolant is cheap. A warped head is not. Third, and this is something a lot of people skip, pay attention to your temperature gauge, especially on long highway drives or during hot weather. Modern cars tend to run at very stable temperatures because the thermostat and cooling fan are electronically controlled. If your temperature is creeping slightly higher than normal or fluctuating in a way it never used to, do not dismiss it. That is your car telling you something changed. Fourth, if your vehicle has a timing belt that is driven in the same system as the water pump, you are typically already replacing the water pump as part of that service at 60,000 to 90,000 miles, depending on the manufacturer interval. That is smart. It is already opened up, so replacing the pump adds minimal labor cost. But if your car has a timing chain and a separately driven water pump, nobody is reminding you to look at it. That is where it gets overlooked. Now, is calling this a scam entirely fair? That depends on how you define the word. Automakers are not sitting in boardrooms laughing about your cooling system. The move to plastic impellers was driven by real engineering priorities: weight reduction, cost control, and manufacturing efficiency. In many cases, the design works adequately for the intended warranty period. Whether that is a satisfying answer when you are facing a four-figure repair bill after the warranty expires is another question entirely. What is reasonable to say is this: some of these components are not designed to last the full life of the vehicle. They are designed to last long enough. And in a world where the average car is now kept for 12 years or more, long enough. And long enough for you are not always the same thing. That gap between what is engineered and what owners expect is where a lot of modern engine failures are born. Here is the bottom line. A 100,000-mile engine failure is not inevitable. It is often the result of a small component doing exactly what it was designed to do. Nothing more, nothing less. The plastic impeller in your water pump was not built to last forever. It was built to last until the warranty was comfortable. After that, you're responsible for knowing it exists, understanding when it is at risk, and deciding whether proactive replacement makes more sense than waiting for a very expensive emergency. The people who avoid catastrophic engine failures at high mileage are rarely just lucky. They are paying attention. They know which components in their specific engine have a track record of failing, and they address those before they become a crisis. Your engine can absolutely go 200,000 miles, but it will not do that by accident. It will do it because someone was watching.